Okay, while we continue on our revision class in Maths 101, today we are going to be entering what we call quadratic equation. Quadratic equation is an equation of this form: ax squared plus bx plus c equals to 0. Quadratic equation is an equation of this form, where a, b, and c are constants. Then this and this is a variable. So an equation whose the highest power of the variable is 2 is called quadratic. I can have an equation like this. The highest, what is here, this a and c here are constants, while x is the variable here, or we call it the unknown. The highest power of the unknown here is 1. This one is called linear. But in this case, the unknowns, the highest power here is 2. This one is called quadratic. So that is how we know quadratic equations. Okay. Now, there are some things we need to know about quadratic equation. What is the unique property of a quadratic equation? The unique property of a quadratic equation is that a quadratic equation can be factorized. Secondly, now, what do we mean by factorization of quadratic equation? When we talk about factorization of quadratic equation, all we mean is that to get the values of the unknown such that if we input them in this equation, it will give us 0. So, since the highest power of the unknown here is 2, when you factorize this equation, you are going to get 2 values of x. That is the x1 and the x2. If the highest power of the unknown there is 3, you're going to get 3 values of x, which is the x1, x2, or x3. Hence, getting the values of the unknown is what we call factorization of a quadratic equation. So any equation that can be factorized can be called a quadratic equation. Okay, coming to factorization, there are many methods of factorization which you must have learned in secondary school. But in this class, in this revision class, I'm going to be introducing the formula method that says to get the value of x, you have plus or minus root or minus b plus or minus root of b squared minus 4ac all over 2a. This becomes the well-known formula method. In this place now, the a is here, this b is this c is this. So when you're given a quadratic equation, you're asked to factorize using the factorization method. I believe you can be able to do that. I'm going to pick one example to show the factorization method. Let me take one example. Okay, I'm going to do it here. If I'm given that 3x squared plus 6x minus 2 is equals to 0. If I'm asked to factorize this, what I'm going to do is my a here is 3, my b here is 6, and my c here is minus 2. So bringing out this formula, it has minus b, so minus 6 plus or minus root b squared, 6 squared, minus 4 times a times c all over 2a, 2 times 3. I pick my calculator to be handy. Now I have minus 6 plus or minus 6 squared is 36 minus, this is 12. 12 times 2 is 24. That's minus 24. 2 times 3 is 6. So here I'm having minus 6 plus or minus 36. Minus times minus is plus. So I have 36 plus 24, which will give me 60. Root of 60 all over 6. Okay? At that point now, we know that root 60 is 2 root 15. So I'm going to be having minus 6 plus or minus 2 root 15 all over 6. So at this point now, I'm going to get my x1 and x2 based on the plus and minus here. So my x1 is equal to minus 6 plus 2 root 15 all over 6. And then my x2 becomes minus 6 minus 2 root 15 all over 6. And this becomes the value of my x1 and x2. So that's what we are trying to say, in the sense that when a quadratic equation is given to me, for me to factorize, I can use my formula method and follow this method, and I'm going to get my x1 and my x2. Okay, that is a simple factorization we have just done there. Okay. Okay, the next thing I'm going to introduce to us is what we call discriminants. Discriminants. Discriminants of a quadratic equation. What we understand by discriminant of it can be gotten from the general formula. Discriminant D is given as b squared minus 4ac. The discriminant of a quadratic equation is a very, very important aspect of that almighty formula per se. It is used in diverse ways. I'm going to show us some of its applications. Number one, remember that there is a method of factorization we call the factorization method. That is that method which you will say you're looking for two values of let me have something like this, ax squared. So we have, let's say, ax squared plus bx plus c equals to 0. When you want to use factorization method, just like you do in secondary school, you will say you look for two values, two numbers that if you add together, it will give you b, and if you multiply together, it will give you c. Now, remember that it's not all quadratic equation that can be factorized by that method. Any quadratic equation that can be factorized using factorization method, it means that that quadratic equation is a complete square equation. So you can use the discriminant of a quadratic equation to make a quadratic equation a complete square. Let's see some examples. Okay, discriminant of a quadratic equation. Let's see one of the first application. Making incomplete quadratic equation a perfect square. Look at this question and say, what value of x? I have 4x squared plus 5x plus q. They say, what value of q will make this expression a complete square? What value of q will make this expression a complete square? So for this to be a complete square, my solution, I'll be using b squared is equals to 4ac. b squared is equals to 4ac. To make a quadratic equation a equation of complete square, you use the discriminant of quadratic equation. So when you see such an equation in the exam, know how to move about it. So b now, remember that my a here is 4, my b is 5, and my c is equals to q. So I'm going to be having 5 squared equals to 4 times 4 times q. 5 squared, I think, is 25 equals to 16q. Therefore, q becomes 25 over 16. So the value of Q that will make this equation a complete square is 25 over 16. What do we actually mean by that complete square? If Q becomes 25 over 16, then this equation can be solved by factorization method if you wish to use that. So that is one example under completing the square, making an equation of a quadratic, making a quadratic equation a complete square, making a quadratic equation a complete square. So that is one application of discriminant of a quadratic equation. Another application of discriminant of quadratic equation is it is used to find the nature of the root of a quadratic equation. Nature of the root. Nature of root is used to find the nature of root. Now, without factorizing a quadratic equation, you can predict how the root will look like. But under these three conditions, first, number one, if the discriminant is equals to 0, then the roots will be real and equal. If discriminant is less than 0, then the roots will be a complex root. And also, if the discriminant is greater than 0, the roots will be real and distinct. Let me explain what we mean here. When you find the discriminant of a quadratic equation and you find out that the discriminant d, the value is equals to 0, it tells you that that quadratic equation, who has that discriminant to be equals to 0, if you factorize it, the value of x1 and x2 you are going to have will be the same. They will be equal, 1, and they will be real numbers. Remember, in our number system revision class, we learned about real numbers. We say real numbers are those numbers that can be found on the number line. So when we say they are going to be real numbers and they are going to be equal, means that the value of x1 and x2 will fall under real numbers and they will be equal. Again, if the discriminant you have gotten is less than 0, maybe -1, -2, -3 is the value of the discriminant, then if you factorize such quadratic equation, the root you are going to be getting will be complex roots. The roots will be complex. Also, if the value of the discriminant equation you get is greater than 0, then the roots of that quadratic equation will be real numbers, 1, and they will be distinct. That means x1 and x2 will be real numbers, but they will not be the same. Such that, let me take an example. If x1 is equals to 2, x2 may be equals to 5. Both of them are real numbers, but they are not the same. Unlike when d is equals to 0. If x1 is equals to 2, x2 will also be equals to 2. So these are the conditions for you to know the nature of the root of a quadratic equation. And remember that d is discriminant of quadratic equation. I'll take one example to drive that point home. Just one example. An example that usually come out in the exam. Okay. Find the value of k. The question says, let's look at what they gave us. 2x squared plus k plus 3. X plus 2k equals to 0. The question now says, find the value of k for which this equation will have equal roots. Good. Find the value of k for which this equation will have equal roots. Okay. It means that we should find what the value of k will be, so that this expression or this equation now, if you factorize it, the value of x1 and that of x2 will be the same. So since the question says we should find the value of k for which the equation will have equal roots, condition for the condition for the root of a quadratic equation to be equal root says that d must be equals to 0. So in this case now, d must be equals to 0. YD is what? B squared minus 4AC must be equals to what? 0. That's the condition. Remember that my A is 2, my B is K plus 3, and my C is 2K. Then I will fill in these informations here. B squared, that means K plus 3 all squared minus 4 times A, 2 times C, 2K. This will give me K plus 3 minus 2 times 4, 8. 8 times 2, 16. 16K all squared. Are we there? So what I'm going to be having there now, this is equals to 0. Hope you still remember. Then this is equals to 0. I can move this 16 here. So I have K plus 3 all squared is equals to 16K. Okay. Mathematically now, I can expand this. I can expand this so that I will be able to do other things. Let's do our simple expansion. We have K plus 3 into K plus 3. This will give me K squared plus 3K. This times this is K squared. This times this is 3K plus 3K plus 9, which will give me K squared plus 3K plus 3K, 6K plus 9. And so if I expand this, I will have this. So bringing it back to what I have, I'm going to clean this side. Bringing it back to what I have K squared plus 6K plus 9 equals to 16K. I can bring this guy back. K squared plus 6K minus 16K plus 9 equals to 0. Okay? So I have 6K minus 16K. 6 minus 16, which will give me minus 10K. So I have K squared minus 10K plus 9 equals to 0. So if I factorize this now, I'm going to get the values of K, which will satisfy that condition. I want to use my calculator to factorize. You can use your general formula, the one we just learned, to factorize. Okay, here I have my A is 1, my B is minus 10, and my C is 9. So I have it that if I factorize this, I have my x1 to be 9 and my x2 to be 1. So what we are saying in essence here is that if the value of x is 9 or the value of x is 1, then this equation, if you factorize it, you are going to have equal roots. Let me check one of them. Now, let's check 1. Let's check 9. That means I can have 2x squared plus 9 plus 3. That is 11. 9, 10, 11, 12, okay? 9 plus 3, 12. So I have 12x there plus 2 times 9, 18 equals to 0. This is the first equation you will get. If you are judging with 1, you are going to have 2x squared plus 1 plus 3 is 4. 4x plus 2 times 1 is 2 equals to 0. Now, if you factorize any of this equation, we are not saying that they will have the same answer. What we are saying is that the values of x for each of, if you factorize this one now, the value of x1, let me do that quickly with my calculator. I have my A to be 2. I have my B to be 12. I have my C to be 18. So here I'll have my x1 is minus 3, x2 is also minus 3. Do you see that the value of x1 and x2 are equal and they are real numbers? Let's see for this one. I have my A to be 2, I have my B to be 4, I have my C to be 2. You see that the value of my x1 will be minus 1 and my x2 will also be minus 1. So what we have seen here is that when the value of k is either 9 or 1, it will make this equation to have equal roots. And the condition we used there was that d is equals to 0, where d is b squared minus 4ac will be equals to 0. Assuming they say we should find the value of k, for which this equation will have real roots but distinct, then I will now say b squared minus 4ac will now be what? Greater than 0. I will solve for this. Remember that this becomes an inequality. But for the exam's sake, I think we should master when d is equals to 0. That is the one that we have seen often in the exam. Okay, I believe this is well understood about discriminant of quadratic equation. I've used it to solve two examples. One, to make a quadratic equation a complete square, and also to find the nature of the root of a quadratic equation. That is discriminant of a quadratic equation. Then the next thing I'm going to pick up here is okay, we want to look at equations with known roots. Now, what we have just done now is that if they give me a quadratic equation, I can give them the roots of the equation. If I'm given a quadratic equation, I can give them the roots of the equation. What if they give me the roots of the equation? Can I give them the quadratic equation? That is the question we want to look into now. So I'm going to take one example from my notes here to run that one. So we call this one finding quadratic equations whose roots are known. Finding quadratic equations whose roots are known. So let me take one example here. This question says, form an equation whose roots are x1 is equals to minus 1 and x2 is equals to 3. We should form an equation whose roots are this. So how do I go about that? Very simple. When I have such in an exam to form an equation, now my answer is going to be a quadratic equation. Remember, when they gave us quadratic equation, we gave them roots. Now they are giving us roots. We have to give them quadratic equation. So I'm going to be saying, I will use this, that x squared minus SORX plus POR equals to 0. I'll be using this skeletal form of quadratic equation. Now, SOR means sum of the roots, while POR means product of the root. So what I'm going to do there is, these are the roots. So SOR, sum of the root, means add the root. So I'm going to have it minus 1 plus 3, which will give me 2. Then POR means product of the root. So I'm going to be having minus 1 times 3, which will give me minus 3. So if I have my SOR to be 2, I have my POR to be 3, then I'll fill in this into the equation. So I have the equation being required as minus, instead of writing SOR, I'll write 2x plus minus 3 equals to 0. So writing it in proper way, plus times minus is minus, equals to 0. This is the answer to this. They asked me that they gave me the roots of the equation and they asked me to find the equation. They gave me the roots. Then I can give them the quadratic equation. If they give me the quadratic equation, I can give them the roots. So I believe that is very, very understandable. Okay. There are also some questions that have been in the exam. Okay, let's look at this one. Let's look at this one. I think this is always a little issue. We are still going to look at past questions and see how these things are. Remember, we are doing revision. It says, let me write it, x squared minus 2x minus 3 equals to 0. Now, this question says, form an equation with roots 3 more. Let me write it somewhere there. 3 more. Form an equation with roots 3 more than the roots of this equation. Form an equation with 3 more than the roots of this equation. So if I have a question like that, that means, first of all, I need to know the roots of this equation. Then the new equation I'm going to form, the roots of that new equation will be 3 more than the roots of this equation. 3 more means 3 plus. 3 more means 3 plus. More means plus. So what I'm going to do is to first of all factorize this equation. So I will use my calculator to factorize. You can use your almighty formula to factorize. Here I have my A is 1. I have my B to be minus 2. I have my C to be minus 3. So if that be the case, then my x1 is 3. Then my x2 is minus 1. So the root of this one is this and this. The new equation I'm going to form will have each root to be 3 more than this. So if the x1 will be greater than the x1 of this by 3, and the x2 of the new equation will be greater than the x2 of this by 3. So it just means add 3 to each of these. So I will have new x1 will now be 3 plus 3, which is equals to 6. Then new x2 will be minus 1 plus 3, which will be equals to 2. So the new roots will carry 6 and 2. Since I now have my new x1 to be 6 and my new x2 to be what? 2. What I'm going to do is I'm going to now use x squared minus SOR plus POR. Okay, so my SOR is 6 plus 2, which is 8. My POR is 6 times 2, which is 12. So my new equation becomes x squared minus 8x plus 12 equals to 0. Final answer. This is the new equation they want me to form. If you watch this equation, if you factorize it, its value of its x1 and x2 is 3 more than the values of the value of x1 and x2 for this one. So that is what the question is trying to say there. So if they can give you a root, you give them the quadratic equation, or they give you a quadratic equation, you give them the root. So from there again, we move to something again. Cubic equations. Now, what do we call cubic equation? It's an equation of this form. If you observe now, the highest power of the unknown here is 3. So this is a cubic equation. It can also be referred to as a polynomial. Okay, it's a kind of polynomial. So in this cubic equation, the highest power of x here is 3. Hence, A, B, C, D are constants, while the x here are the variables. So how do you factorize a cubic equation? You first of all get the, here I'm going to get how many values of x? 3. So to get the first one, we do trial and error method. Okay, and that trial and error method, first of all, you are going to, when you use trial and error method, you get the first value of x. Then the second value of x, you divide the equation by that first one. Let's take one example so that we can drive the points home very, very well. One example, and everything will be looking clear. Everything will be looking clear. So, okay. Look at this equation. X cubed minus 5x squared minus x plus 5 is equals to 0. They asked me to factorize this. Okay. If I'm to factorize this, first of all, I will obtain the value of x by trial and error. When you want to do your trial and error, you start from -1, you try -1, you try 1, you try -2, you try 2. When I mean by you try -1, what do I mean? What you're going to do is, you say let x be equals to -1. Let x be equals to -1. So anywhere you see x here, you put -1. So you see we have -1 cubed minus 5 into -1 squared minus -1 plus 5. Will this give me 0? You check. -1 cubed is -1. This is going to give me plus 5. Because -1 squared is 1 times 5. Okay, this will give me -5 also. Then minus is plus 1 plus 5. You see, this will take away this. This will take away this. So if the value of x is equals to 1, you see that the whole of this becomes 0. So that means for the first case, x is equals to 1. That gives you the first value of x. Remember, you are looking for x1, x2, x3. Okay, so let's divide this now. We have x plus 1. We now divide the whole of this. X cubed minus 5x squared minus x plus 5. At this point, x cubed divided by x will give me x squared. X squared times 1 will give me x cubed. X squared times 1, x squared times x will give me x cubed. X squared times 1 will give me plus x squared. This times this gives this times this gives this. Then close this and put minus outside. Close up. Now, minus times x cubed. Minus times x cubed has become minus x cubed. So x cubed minus x cubed. X cubed minus x cubed, 0. Minus times plus is minus. So we have minus x squared here. Minus 5 minus 5 minus x squared. Minus 5x squared, which is up. Minus times plus is minus. Minus 5x squared. Then we have minus x squared. We have up minus 5x squared. Then minus times plus is minus. So we have minus x squared. So you have minus 5x squared minus x squared, which will give us minus 6x squared. Okay, so I have minus 6x squared. Nothing happened to this and nothing happened to this. I believe that first step is okay. Let's look at the second step. This is the first person carrying x. I'll do 6x squared divided by x. 6x squared, which will give me minus 6x. Okay. Minus 6x times x will give me minus 6x squared. Minus 6x squared. Minus 6x times 1 will give me minus 6x. Remember, you bracket what you have got and put minus outside. Now, minus times minus is plus. So what I'm going to be having here is minus 6x squared, then down, plus 6x squared, which will give me 0. So this will give me 0. Then here I'm having minus x up, then down, I'm going to have a minus times minus plus 6x. Minus 6x plus 6x, which will give me 5x. So I have 5x here. Bring down the plus 5. We didn't use it. Now, 5x divided by x will give me plus 5. So 5 times x will give me 5x. 5 times 1 will give me 5. Remember, we still close this one and put minus. So what I have here is 5x minus 5x. That is 0. Here I have 5 minus 5, which will also be 0. So if you observe now, this has finally divided this to give us no remainder, and this is our quotient. So what we are interested here is the quotient. So we pick our quotient and move on with that. Our quotient here now is written as x squared minus 6x plus 5, let's say, equals to 0. If I factorize this quotient, which is now a quadratic equation, I'm going to have 2 values of x. That 2 values of x plus the 1 value of x I've gotten before will give me 3 values of x. Then I've completely factorized this. So I will use my calculator to factorize this. So I have here I have my a is 1, my b is minus 6, my c is 5. In that case, I'm going to have my x2 to be 5 and x3 to be 1. So finally, if I factorize this, I have my x1 is equals to minus 1, x2 is equals to 5, and x3 is equals to plus 1. That are the 3 values of x that you get by factorizing this cubic equation. That's what we are going to get by factorizing this cubic equation. So these are the 3 values of x we are going to get when we factorize this cubic equation. Okay. The next thing we are going to go into now, we have seen cubic equation. The next one we're going to go into is what we call radical equations. Radical equations. Radical equations. In this radical equation, I'm going to use an example to drive the point home. Radical equations. Okay, look at one example here. There's a solve the equation y minus 11 root y plus 24 equals to 0. And so we should solve this equation. This is a kind of radical equation. If you look at it, observe very well. When you see something like this, it is called a radical equation. So what I'm going to do is to work on this. I will say, let t be equals to, I can say let x be equals to root y, so that x squared becomes y. So anywhere I see y, I can call it x squared. Anywhere I see root y, I can call it x. Then put it back into the equation. I'm going to be having y x squared minus 11x plus 24 equals to 0. Okay? So that by the time I factorize now, I'm going to use my calculator to factorize. So I have my a to be 1. I have my b to be minus 11. I have my c to be 24. And I have my x1 to be 8 and my x2 to be 3. So having gotten that, I will now not stop here. I will say if x squared is equals to y, because I'm looking for the values of y, not actually x. If x squared is equals to y, okay, so that, or you say, or y is equals to x squared. So I will now say when x was equals to 8, y is equals to x squared, then y will be 8 squared, which is 64. I believe so. 8 squared, which is 64. Also, when x is equals to 3, y will be 3 squared, which is equals to what? 9. So therefore, the value of y1 is 64. When x is equals to 8, y is 64. When x is equals to 3, y is 9. That is why we call it radical equation. So we are looking for the values of the unknown, which is y. So look at how we first of all converted the values of the unknown into x. Then we started working on it. At the end of the day, we still return the values of our y. This is always a customer in the exam. So we call this type of quadratic equation radical equation, should you see one of it there. Okay. The next one we look into is symmetric equations. Symmetric equations. Symmetric equations. In this one is the one you call alpha and beta. Alpha and beta. So when we come to alpha and beta as for symmetric equations, first of all, we need to know some important derivatives, and which are alpha squared. First of all, alpha plus beta is equals to SOR, which is equals to minus B over A. Alpha beta is equals to POR, which is equals to C over A. Having known this, alpha square plus beta square is alpha plus beta all squared minus 2 alpha beta. Also, we have alpha cube plus beta cube is going to give me alpha plus beta into alpha square plus beta square minus alpha beta. And the last one I will present here is alpha minus beta all squared. This will produce me alpha plus beta all squared minus 4 alpha beta. Now, someone might ask, do I need to cram all this? No, memorize them. Have them somewhere, so that when the question comes, you can always give its equivalent. Okay? So this is equals to this. This is equals to this. This is equals to, and we are going to be using all these things in solving as we move on. So just like in we have been saying before, they can give you a quadratic equation, you give them roots. They can give you the roots of a quadratic equation, you give them the equation. So the questions that comes out from here, the first type is they will ask you to form an equation. Form an equation whose roots are, they give you alpha and beta. Then another question they can ask you, say, find the value. So we're going to see one question for each of them so that we can drive the point home. Okay, let me pick one question from here. This one says, form an equation. If alpha and beta are the root of this equation, okay, let me put it that way. If alpha and beta are the roots of this equation, then I'll say form an equation whose roots are, I'll take only one, form an equation whose roots are 1 over alpha, 1 over beta. You have many of these in your question and your mathematical workbook. If alpha and beta are the roots of this equation, form an equation whose roots are 1 over 3, 1 over alpha over 1 over beta. Now listen very well. Don't make this mistake in the exam. If I'm going to form an equation, what they are going to give to me is going to be separated by a comma. But if I'm going to find a value, they will not be separated by a comma. Watch, this one is separated by a comma. So I'm going to find an equation. So what I'm going to do first is to find the SOR here, find the POR here, then find the SOR for this, find the POR, then form the equation. Watch what I'm going to do there now. First of all, there I will say A is 1, B is 4, and C is minus 2. So that SOR is minus B over A, which is minus 4 over 1, which will give me minus 4. Okay, that is my SOR. I need to find my POR. Okay, my POR is C over A, which is minus 2 over 1, which is going to give me minus 2. Okay. Then the next thing is now I'm going to find another SOR, but in this case now I'll be adding this. So I'll say another SOR, which is for the new one. I call this one the old ones, because it was gotten from the primitive equation. Now I'm calling this one the new one. The new SOR, I will have this plus this. 1 over alpha plus 1 over beta. Normal, I'm going to take LCM if I'm to add these two. Then this will give me beta plus what? Alpha, which is something as alpha plus beta over alpha beta. So if I add these two things together, I will have this. So further, alpha plus beta, which is SOR is minus 4. Alpha beta, which is POR, is minus 2. And that will give me 2. I've got my new SOR to be 2. My new POR is going to be 1 over alpha times 1 over beta. I multiply the 2. This becomes 1 times 1 is 1. Alpha times beta is alpha beta. And this will produce me 1 over alpha beta product minus 2. This will give me minus 1 over 2. So I've got my POR now. Then, what I'm going to now form is the equation that we have this as its SOR and have this as its POR. So I'm going to have in that equation as, remember that we have that x squared minus SOR or x plus POR equals to 0. So my x squared minus, what is my SOR? Minus 2 is 2. Then my POR is minus half equals to 0. So I try to simplify. This will give me x squared minus 2x minus 1 over 2 equals to 0. We don't accept a fraction there. So I multiply everything by 2. Will give me 2x squared. Will give me minus 4x. Will give me minus 1 equals to 0. This is the equation I'm looking for. So you see, multiply once you have the denominator, you use this denominator to multiply everyone. So we have this 1 over 2 times 2 over 1. We remove this 2, giving us with minus 1. You also multiply this times 2, we give you this times 2, we give you this, and this is the equation. So mark it. They gave us this, and they say that the root of these equations are alpha and beta. So we should form an equation whose roots will be 1 over alpha, comma 1 over beta. So what we will do there is, first of all, get SOR from here, get POR from here, keep them. Then you now get your new SOR, which is adding what they've given to you. Whatever is there, just try to add it together mathematically, get whatever it is. Then when you get it, you'll be seeing that these things will be functional inside that work. So you will get that. Also, multiply them to get the POR, and you have that. Then input it into this equation, and you are going to get what they ask you to do. That is one. The next one can ask you to find the value. Find the value. Let's see an example under that. Remember, I'm taking just 1 examples. 1 examples. Okay. Let me take another example. Okay, look at the question. It says 2x squared plus 5x plus 3 equals to 0. Then I'll say if alpha and beta are the roots of this equation, we should find the value of alpha squared plus beta squared. You observe now, when they say find the value, they don't separate these two guys by comma. It is plus or it can be minus, not comma. So here we are going to find value, a number, not an equation. So what I'm going to be having there now is a solution. I'm going to first of all ask myself, do I know the equivalent of this? Yes. Remember, I gave us the equivalent of that while we start. I remember that alpha squared plus beta squared is equals to alpha plus beta all squared minus 2 alpha beta. So if that be the case, then I'm going to get my SOR here and get my POR. My SOR is minus B over A. B is minus 5 over 2. Then my POR is C over A. My C is 3 over 1, which is equals to 3. So I've got my SOR, I've got my POR. Then I put the values inside here. Putting them here, I have alpha plus beta square means SOR squared. That is minus 5 over 2 all squared. Alpha plus beta all squared, meaning SOR squared. SOR squared. Are you there? Then minus 2 into alpha beta product, which is 3. This will give me 25 over 4 minus 2 times 3 is 6 over 1. And if I systematically work on that, you can use your calculator to help yourself out. And if you do that, you'll get your answer to be 13 over 4. Okay, get your answer to be 13 over 4 there. So this brings us to the end of everything that the school wants us to learn under quadratic equation. So we are going to look at past questions, then we'll now call this topic a day. So looking at the past question, we're going to see in 2020, 2021, which is the first year you see there, there's a question in question number 8. Find the quadratic equation whose roots are minus, I see. Find the quadratic equation whose roots are, they gave us the root to be minus 1 over 2 and 3 over 2. They ask us to find the quadratic equation whose roots are this and this. Remember that I'll first of all say that I have x squared minus SORX plus POR equals to 0. So if I have this, so SOR means I should add them. So I have 1 over 2 plus 3 over 2. I want to use my calculator to be fast about that. So I have 1 over 2 plus 3 over 2. That will give me 2. So 1 over 2, oh, minus 1 over 2, sorry. Minus 1 over 2. Minus 1 over 2. Okay, let me delete that very well and do the writing. Minus 1 over 2. Then plus 3 over 2. That gave me 1. So minus 1 over 2 plus 3 over 2 is equals to 1. Dot of minus 1 over 2 times 3 over 2. Minus 3 over 4. So what I'm trying to say here is my SOR is equals to 1. My POR is equals to minus 3 over 4. So we put it into there. We have x squared minus SOR is 1. X plus minus 3 over 4 equals to 0. Remember that this denominator, we have to work on it. So we have 4x squared minus 4x minus 3 equals to 0. And that becomes the equation we are looking for. So that will end with option 4x squared minus 4x plus 3. Option B, 4x squared minus 4x plus 3. So the next question is in question number 9. Question number 9, no, that's not it. let's go to question number 15. Question number 15. Question number 15. We'll visit that question number 15 later. Okay. The next question is question number 1, section B. Question number 1, section B. It says, if alpha and beta are the roots of this equation, form an equation which roots are alpha square and beta square. It says, if alpha and beta are roots of this equation, 3x squared plus 5x minus 1. If alpha and beta are roots of this equation, form an equation whose roots are alpha square and beta square, which can also be written as alpha square comma beta square. It is not alpha square plus beta square or alpha square minus beta square. So this one will be equation. So what I'm going to do there, I'm going to find my old SOR, which is minus b over a, which is minus 5 over 3. I'm going to find my old POR, which is c over a. I have minus 1 over 3. So my new SOR will be alpha squared plus beta squared. If you do alpha squared plus beta squared, it will give you just one thing which we have done before, which is alpha plus beta squared minus 2 alpha beta. I believe I'm correct in that. Let us check out from our book again. This is something as alpha plus beta all squared minus 2 alpha beta. Okay, let's simplify further. Alpha plus beta gives you SOR, which is minus 5 over 3 all squared minus 2. Alpha beta give you product minus 1 over 3. If I have that, I'm going to be having, this is 25 over, this is 9 minus 2 times minus 1, that is 2 over 3. So using my calculator to find 25 over 9 minus 2 over 3. That will give me 19 over 9. So that is my SOR. I'll also find my POR, which is alpha squared times beta squared. Alpha squared times beta squared. Okay, so now that we have our new SOR to be this minus this, if you press this in calculator, it will give you that our SOR will equals to 31 over 9. So the next thing we need to look for is our POR, the new one. And it's going to be alpha square times beta square. This is the same thing as alpha beta all square. This and this are the same. And my alpha beta is minus 1 over 3 all squared, which will give me 1 over 9. That will produce me 1 over 9. So using my x squared minus SOR or x plus POR, I have my x squared minus SOR is 31 over 9. POR is 1 over 9 equals to 0. They all have the same. I'll multiply everywhere by 9. So I have 9x squared minus 31x plus 1, which will give me 0. This is the final answer to question number 1, section B for 2021/2022. The next one we go into is 2020-2021. So we are going to 2021-2022. There we have question 2, section B. Question 2, section B. Go to section B. Question 2, okay? I'm there. It says, find the quadratic equation whose roots are, they gave us the root of the equation and they say we should form the quadratic equation. I think we have done that before. You can use the leverage from there. Then the next question I'm seeing here is question 3. If alpha and beta are roots of this index equation, find the value of alpha plus beta. Okay, value of alpha plus beta. Okay, if we are to find that, I think that was solved properly in the past question, section B. Question number